Students, welcome to Legend Lens, and today you're going to have a look at exponential form of a complex number. Now, we've already said that a complex number could be represented or expressed in three forms, which is the vector form, the polar form, and the exponential form. We've already seen the vector form, which is in the form of a plus bi, in the polar form, r multiplying the cos of theta plus I sin theta. And so today we look at the exponential form, which is also in the form of that. Alright, so let's start. Now, many functions can be expressed as series. As we can see over here, we have the function ES being equal to 1 plus x squared over 2 factorial plus the rest, and the sign, which is also expressed in series in the form of that, and the function cos also in the form of that. This is not for you to have a hazy recollection of them. It's just something that you should take note of. Alright, so now when we take the first function, what is ex, let's make s to be equal to I theta. So then when we put it in the series, what do you get? What we are actually going to get is going to be 1 plus I theta plus I theta all squared over 2 factorial plus I theta all cubed over 3 factorial plus I theta exponent 4 over 4 factorial plus I theta all exponent 5 all over 5 factorial plus dot dot dot. Alright, so we continue. We get 1 plus I theta plus I squared theta squared over 2 factorial plus I cube theta cube over 3 factorial plus I exponent 4 theta 4 over 4 factorial plus I exponent 5 theta exponent 5 all over 5 factorial. Now we know I squared to be -1, I cube to be negative I, 4 to be 1, and I5 to be positive I. So now we get 1 plus I theta minus theta square over 2 factorial plus minus theta cube I theta cube over 3 factorial plus theta exponent 4 over 4 factorial plus theta exponent 5 over I theta exponent 5 over 5 factorial. So now what we do now is to group the real part and the imaginary part. So what do you get? We have 1 minus theta squared over 2 factorial plus theta exponent 4 over 4 factorial. Then with the imaginary part, we get I theta minus I theta exponent 3 over 3 factorial plus I theta exponent 5 all over 5 factorial. So now what we get is 1 minus theta exponent 2 over 2 factorial plus theta exponent 4 over 4 factorial plus, then bringing the common factor out, which is I, you get theta minus theta exponent 3 over 3 factorial plus theta exponent 5 over 5 factorial. So now we can see that this series is actually equal to the cos series that we have here. It's 1 minus s squared over 2 factorial. When we check this one too, we have 1 minus theta squared. Then in this sense, the s is going to be theta. And so in place of this series, we can put cos theta over there. Similarly, when we check this series as well, we can see that it's also equal to the sine series that we have here, which is x minus s squared s cubed over 3 factorial over here. So in place of this one, you can also put sine theta over there. So we get our e exponent I theta to be equal to cos theta plus I sine theta. Now we know our polar form to be equal to r multiplying cos of theta plus I sine theta. And then from here, we've derived that cos theta plus I sine theta is actually equal to e exponent I theta. So in place of that, we get r e I theta. So this is what we call the exponential form of a complex number. So here we've actually obtained the exponential form from the polar form. So because of that, it is easy to obtain the exponential form of the complex number from the polar form. But then the value of r and theta are the same in both cases. However, in the exponential form, the angle is in radians. The angle must be in radians. And then with the polar form, the theta or the angle is in degrees. That's basically the difference between the polar form and the exponential form. So now let's take this example. We have this complex number which is in the polar form, and we have to express it in the exponential form. So our exponential form should be in the form of RE I theta. So our R from this is 5 and our theta is 60 degrees. But then, as I said, in the exponential form, your angle should be in radians. So 60 degrees in radians is pi out of 3 radians. So simply our exponential form of expression becomes 5e I pi over 3. That's as simple as that. Thank you very much, guys. Subscribe for more of this. Thank you.